Hi class. We spent a lot of time looking at the differences between the different protocols and the different portions of IP versions 4 and IP version 6. Let's talk a little bit about the transition and the interoperation of the two releases or the two versions. So when we look at moving from IP version 4 to IP version 6, during the transition, there will be a lengthy period of time when you're going to have both protocols existing side by side. IP version 4 and IP version 6 devices and networks will need to be able to communicate with each other, and IP version 6 packets will need to find a way to cross over IP4 only network domains. Obstacles to this transition include the IPv4/IPv6 interoperability and the complexity of planning and implementing migration mechanisms, the availability of the IP version 6 addresses from service providers, and the enormous investment of time and resources required by the private and public organizations worldwide. There's several different 4 to 6 hybrid networks and nodes that can be used to facilitate the transition, depending on the organization's need and the transition stage it's moving into. The basic hybrid model allows the IP version 6 networks to communicate with each other over an IP4 backbone network. With that, it invokes a straightforward process in which packets from the IPv6 node are encapsulated into an IP4 header by the IPv6 gateway, and then gateway router, and then transmitted over the IPv4 internet to the receiving IPv6 network and node. Although the IP version 4 header would be routed across potentially multiple IPv4 routers between the source and destination, the IP version 6 network's point of view, it's as if it had an end-to-end tunnel was constructed directly between the IPv6 source and the IPv6 destination. A nested hybrid model works on a similar principle, but there are IPv6 networks more likely exist with a larger IPv4 LAN. So a true hybrid network is going to consist of a mixed set of the IP version 4 and IP version 6 subnets, and all of them are going to interact on an IPv4 LAN and communicate off of the LAN across the IP version 4 internet. Regardless of the model addressing during the transition process, it must allow devices to perform the 6 to 4 packet to use the IPv4 source and destination addresses so it can carry it across the IPv4 internet and arrive at its IP version 6 destination. So when we look at the transition mechanisms, we can use either a dual IP layer architecture or a dual stack architecture. A dual IP layer architecture allows a device using both the IP4 and IP6 to create packets by using a common source for upper layer TCP and UDP protocols. For a device using a dual stack architecture, each network layer protocol uses a separate transport layer stack. In other words, on a computer capable of using both IPv4 and IPv6, the IPv4 would access its own dedicated stack for the TCP and IP, and the IPv6 would access a separate and dedicated transport layer stack. Sorry. Uh, Regardless of which stack architecture is being used, the IPv6 over IPv4 tunneling is the common transmission mechanism to send the IPv6 packets over an IPv4 network domain. The DNS infrastructure in the transition network must be able to manage for A and the AAA records in order to resolve domain names, both for IPv6 and IPv4 addresses. This requirement not only for network name servers, but also for the name resolvers that are running on the individual network nodes. When we look at the 6/4 tunneling, it involves different device configurations depending on the tunneling mechanism being employed. You've got your router-to-router components, typically involving router devices that are both IPv6 and IPv4 capable. They are most commonly used if creating the endpoints of the tunnel across a large IPv4 domain. Host to router and router to host, then configuration represents the first and last legs of the network packets journey. With the IPv6 sending the host, creates the IPv6 packet and sends it to its gateway router. The router then encapsulates the packet into an IPv4 header and sends it out public IP4 interface. Then at the opposite end of the tunnel, the receiving router accepts the packet, strips off the header, and then forwards the IPv6 packet onto the interior IPv6 facing interface to the receiving IPv6 node. If we look at then the host-to-host configuration, it's going to allow the sending of the version 6 host to create a virtual end-to-end connection to the receiving host without relying on a gateway to perform the encapsulation and tunneling. There are three different tunneling mechanisms. And the first one we're looking at an automatic tunneling mechanism that's going to allow the version 6 network nodes to communicate across the version 4 network through router to IP6 capable network. With that, the nodes use specially formatted addresses based on the identifier combined with the IP4 address of the device's private unicast address. Excuse me. With that, then both the nodes and the routers have the option of using an on-link route or a default route. For nodes with the on-link route, it lets them send traffic directly to the other nodes, and its default routes to the router when the traffic addresses it on an IP version 6 node. With that, then it routes using the on-link route for traffic to the subnet, and then default route to the next hop router on the IP version 6 capable network. 6/4 is IP version 4 to IP version 6 transition technique and technology, and it's characterized by its ability to allow the version 6 packets to be sent across the version 4 networks, and then the use of the relay servers. Key thing about 6/4, it's special relay servers facilitate communication between the 6/4 sites over the IP4 networks. This does away with the requirement of configuring tunnels across the IP4 infrastructure. 6/4 components include the 6/4 nodes, the 6/4 routers, the 6/4 relays, and then the 6/4 nodes routers. A 6/4 node is then a PC possessing one or more of the IP version 6 addresses. The 6-to-4 router then uses the 6-to-4 tunneling interface to relay communication between a 6-to-4 node and other 6-to-4 devices that could be including the routers, the relays, and the nodes. A 6-to-4 relay then is a specialized device that acts as an IP version 4 to IP version 6 router and can forward 6-to-4 address packets across the version 4 networks. A 6-to-4 node router is a version 4.6 device that causes the 6-to-4 tunneling interfaces to send and receive 6-to-4 address packets. With that, then it can be used together on the network to communicate when a 6-to-4 router is manually configured as a router, and then isolate the node to locate the 6-to-4 router and receive the router advertisement. Another IP4 transition technique is characterized by the unique ability to operate behind routers and broadband devices with a NAT-enabled nodes that can communicate across the IP4 networks by encapsulating the version 6 packets inside the version 4 UDP datagrams. The components include the server, which is an IP4.6 nodes that pass the traffic between the 6 sites and the 4 networks. You've got your relays, which are 4.6 routers that use the host-to-router and router-to-host tunneling to forward the packets, and then your clients on the IP version 6 capable networks across the IP version 4 networks, and then the host-specific relays, which are the 4 to 6 nodes directly attached to both a IP4 internet and the IP version 6 internet, and communicate with the nodes without going through the relay. I hope you have found this information useful, and we'll continue on from here.